Let's get started on our next project, Dodgeball. So we'll be making a dodgeball game. Have you ever heard of dodgeball? If so, we'll be making a game where the player must dodge moving balls to reach the end of the level. The player will use the arrow keys to move their sprite. They will also be using the space key in order to jump. If you make it all the way to the end, you win. And there are a couple components we'll be learning from this project, such as how to use the keyboard to move a sprite, how to use if-then-else blocks, how to use variables, how to use broadcast blocks, and how to create clones, and how to draw your own sprites. So let's get started. To get started on today's project, we'll be remixing a project that has a background drawn in for us. Let's go to this link. That way we can press on the green remix button and you are ready to go. Once you click on the green remix button, you will be inside the editor. Notice you have some lasers and the stage already drawn for you. Let's go ahead and choose our player sprite. Choosing our player sprite. First, choose a sprite for the character you want to play as. If you remember from previous clips, choosing a sprite is pressing the blue cat face button in the bottom right corner of the screen. I recommend choosing a character with multiple costumes so we can make it look like they're walking. So let's go ahead and choose a sprite with the blue cat face icon. And like mentioned, let's choose a sprite with multiple costumes. So if you hover over some of these sprites, you will notice that some of them are either still or they have some animation to them, meaning that they have multiple costumes. So I suggest choosing somebody that looks like they are walking. Perhaps the bear walking or the dog. Perhaps you are Jija walking. There's a lot of options to choose from, like the lion. And I'm gonna go ahead and choose Pico walking. Of course, feel free to modify your sprite by going under the stage and readjusting the size. I suggest resizing your sprite to at least half the size of the first floor. So again, half the size of the first floor. That way when we add in our jumping capabilities, our heads do not get stuck on the upper part of the level. So make sure your sprite is a good size to walk with and jump with. And then we can move on with moving our sprite next. Making our character move. Now that we have our sprite, we need to add movement to it. So first, let's make our character move to the right. We can do this by triggering our program when the flag is clicked. Then we want our sprite to go to coordinates and then loop in the forever. If the right arrow key is pressed, and then point in direction 90 and move 5 steps. If your sprite happens to have more than one costume, you can also add a next costume code block. So feel free to try out this code. So feel free to pause the video, or let's move on to coding it ourselves. So when the flag is clicked, we will go to certain coordinates and then forever check to see if the key right arrow press is triggered. Then we will point in direction 90 and move 5 steps and switch between next costumes. So let's trigger our program when the flag is clicked. And we want our sprite to go to somewhere. So make sure you are coding inside your player. That way your player can go to certain coordinates, such as the coordinates we have listed. Let's do x as negative 213 and y as negative 140. Then we can consistently check if key right arrow is pressed. So we can use a control to forever repeat an action. And if a condition is true, it will happen. So our condition this time is that the key right arrow is pressed. So we are sensing something in our program, that a key is pressed. The key we are assigning is the right arrow. And if key arrow pressed, we will point in the direction 90 and move 5 steps. If our sprite happens to have more than one costume, we can also add in that code block. Let's try it. We are going to move 5 steps while pointing in the direction 90 because that is to the right. And my Pico walking happened to have some costumes with it, so I'm going to add in a next costume block. So let's click on the flag. And if you click on the right, you will notice that Pico is walking and his feet are moving. Now notice that my sprite is hovering above the ground. So depending on how you modified your sprite, your feet might be in the air. Now a way to modify your sprite to be on the ground is to edit the y-axis. Since the y-axis determines how high and low we are, let's put our character a little more lower since we're still in the sky. So this is your chance to play with your X and Y coordinates to make sure that your player is in the right spot. So I'm going to edit my coordinates to go a little more downward, maybe -50. And you'll notice that the sprite adjusted itself. So I'm just going to play with the numbers a little bit until my sprite is on the ground. So once your sprite is on the ground, then you can try your walking code again and see if it looks natural. So right now we can only walk to the right. Can you guess how to do the left side? If not, let's move on to making the left side. Let's make our character move to the left now since we can only move one direction. Here's a hint. We're going to add it to the inside of our current forever loop. So now our new trigger will be if the left arrow key is pressed, then move in the direction -90 and move 5 steps. So this is going to be inside our forever loop. So let's try it out together. We have a new condition, so let's add in a control to add in a new if statement. And make sure our if statements are separated by one another and that they are not inside one another. So let's trigger our new key pressed. Instead, we are triggering the left arrow. And more or less, we're using the same code with some few tweaks and changes. So instead of pointing in the direction 90, so let's use the motion block point in direction 90. But instead of 90, which is to the right, let's make it go to the left, which is -90. Let's go ahead and move 5 steps again. Since we're pointing in the direction -90, it should move us to the left. And then we can add in a next costume block. That way our character still seems like it is walking. And if you try your code, you should be able to walk still to the right and to the left. But if you notice, there are some glitches that come with this. Can you figure out a way to fix the glitch? Let's go by modifying our sprite again, and let's fix our turning upside down glitch. Here's a recap of what we've done, and here's our finished left and right code. So if you finished your code, it should look something like this to see if your character moves to the left and to the right. And if you click the flag in your program, you should be able to walk to the right and to the left. And let's fix our flipping upside down glitch next. But make sure you have our finished code for moving left and right. And let's move on fixing our glitch next. let's fix our glitch by fixing the flipping character. So when you tested out your game, you noticed something weird, and that was that our character, whenever we turn to the left, it flips upside down. So let's fix the rotation style with this. So, did your character flip over when you click the left arrow key pressed? So under the stage, we'll click on a wheel that says direction 90, then click on the button which the like two arrows are pointing like each other. So let's navigate to the bottom of our stage till we find direction 90. And if we look under the big wheel on which direction we are facing, let's click on the two arrows facing each other called left and right. What this means is that now the orientation style of the sprite can only move left and right. And once you have the two arrows highlighted, clicked on, and that it is blue, now when you test out your program, you should be able to walk to the right and left without flipping upside down. And that will fix your glitch on flipping upside down. The next step we will work on is making our character climb the pink ladder, since for now we are stuck on the first floor. So for the next step, walk up to the pink ladder and let's see how we can code to get up there. Making our character climb the pink ladder. So in our background that we borrowed, there's a pink ladder that our character can climb. So when we click the up arrow and we're touching the pink ladder, we want our character to move up to the next floor. And we can do this by adding a new condition. So here's a hint. Let's add this inside our loop. So if we are touching the color pink and key arrow press, then we can change Y by 4. So let's make sure we add in a new if condition to our forever loop. Let's make some room by zooming out of our environment with the magnifying glass. And we have a new control with a new if condition. So make sure it is separated again. And we have a new key press triggered, which is now we are going up. But before we go up and click the up arrow, we want to make sure two conditions are true at the same time. So we are going to use an operator called AND. That way two actions are true in order for this condition to follow through. So our condition is that key up arrow has to be pressed and we have to be touching the pink ladder. So again, we are sensing that we are touching a certain color. And if you remember from last class, let's fill the color of the pink ladder using the filler tool. And let's select the pink ladder. That way both conditions have to be true. If key arrow pressed and touching the pink ladder. If we are doing both and we are on top of the pink ladder, we can change the y-axis by 4. That way we move up the ladder. So let's use a motion block called change y by. And let's change y by 4. And your code should look something like this, added to our current forever loop. So now if you are to walk up to your ladder, or better yet, before the ladder, if you try clicking up arrow, nothing will happen. But now if you were to walk up to the pink ladder, you will be able to go up, walk across the second floor, and make it to the second ladder and reach to the third floor. So see if you can reach up to the third floor all by yourself when adding this code. And since we made it to the top, here's a challenge. Can you make your character say something at the end? How can we make our character say you win at the end of our course? So once we click on that, or once we touch the green bar at the end, we should say something. Feel free to try out this challenge. Here's the answer to the challenge. So this would be very similar to the if statements we did for the ladders, except this one's so much easier. Here's a hint to try solving it on your own. So here's a hint. Check forever if touching color green, then say you win congrats for 2 seconds. Feel free to modify what you say. Then we need to tell our program to stop all. So let's try out the code. We need a new condition, a new if condition. So let's go to control and add in a new if statement to our program. And now our condition is if we are touching the green bar at the end. So we are sensing that we are touching another color. And let's fill that color. That way we are certain that that is the right color we are triggered by. So if we are touching the color green, let's say something that our character can say. Let's say, you win. Congrats. And to make sure your program stops running, let's make sure we go to controls and make sure your program stops all. And make sure your stop all is inside your if statement again, because if your stop all is outside of the if statement and you try running your program, it will be forever stop all. So make sure that your stop all is inside the loop. That way, when you are walking, everything can be triggered properly and everything is running, such as touching the color pink and up arrow pressed, moving left and right. Now if we are touching the color green, you win congrats, and you won't be able to move your player away from the screen. And this is the final code you should have inside your forever loop. So let's add some gravity to this, because for now, if we are to walk off our platform, let's try from the second floor. You'll notice that there's no gravity in our program. So let's go ahead and add some gravity, that way we can fall down if we were to walk off the edge. So let's talk about gravity. Do you know what is gravity? So gravity is what keeps us on the ground. We're going to add some gravity to our game. That way if we were to walk off the edge, we will fall down. So let's create a variable called gravity in our program. So let's hover over to the variable categories. That way we can make a variable called gravity. So let's name our new variable called gravity for all sprites. And then we can click on the word OK. And you should see the word gravity appear on your stage. Now gravity isn't that useful for gamers to know, and it's not keeping track of anything specifically. So let's uncheck it from our variable category. That way we don't see it on our gaming screen. And setting up the gravity. So it is time to set up our gravity effect. So when we are not touching the platform, we'll be dragged down by the gravity. So here's a hint. When the green flag is clicked, we will set our gravity variable to -4. Then check forever to see if we are not touching blue or touching the color pink. Then change Y by the gravity. So let's add this code to your character and test out your gravity by jumping off the second floor like I tried. So let's go ahead and add the new trigger when flag clicked, and let's set our gravity variable to -4. So let's zoom out of our coding environment and let's make some room for other scripts. That way we could trigger our new program, our new code in our program. So when the flag is clicked, we want to set our new variable gravity. We're going to set our gravity to -4. That way our gravity brings us down. And then we want to check forever if not touching the color blue or pink. So let's use a forever loop, a control, to forever check if the condition is ever true. And our condition is that we are not touching the color blue or the color pink. So either or can happen. So that's an operator. That if we are not touching either or, this condition can follow through. And our condition is that whether we are touching the color of the floor, the blue floor, or we are touching the color of the pink ladder we are climbing. Because if we are not on either of these colors, that means we are in the air. So gravity should go into effect. So if we are not touching either of those colors, we will change Y by the gravity. So again, we are not touching either of these colors. So make sure that we are not touching color blue or pink. So let's add in another operator called not. That way we can check the condition if we are not touching either of these colors. If not, we will change Y by the gravity. So let's use a motion block since Y will bring us down. So let's change Y by, we don't have a certain number, but what we did is we made a variable to hold that value, which is -4. So therefore we're going to put in our gravity variable. And let's test it out. Walk up to the second floor or the third, and now if you were to walk off the platform, it will drop you to the ground. I'll try that again. I have now gravity in my program. Let's try it on the third floor. Now if I were to walk off the edge, now I can fall off. Or I run back and fall off the second floor. So our gravity seems to be working great. And this should be the code you have for setting up gravity. Let's work on jumping next. Jumping. So we need to make our character jump. That way we can jump over the balls. So first let's create a variable called jump height, which will be used to see how high our player can jump. So let's click on make a variable button and let's title it jump height. So if you ever want your player to jump higher or lower, you can change the value of this variable. So let's go ahead and name our new variable, make a new variable called jump height. And let's do this for all sprites. Again, our players don't need to see how high we jump in our game. So let's uncheck it from the variable section. And let's go ahead and see what we need for jumping. So now that we actually add the code for our jumping player, let's see how we can do this. So when we press the space key, we can set our jump height to 11 and then add a repeat until loop and check until the jump height is equal to 0. So if we jump up 11 pixels, we should be able to decrease it back to 0. That way we're back on the ground. And inside this loop, change Y by jump height and change jump height by -1. Then wait 0.2 seconds outside the loop. So let's add this code into our player sprite and test it out. So we have a new trigger, when space key pressed, and we set how high we jump to. So let's make some room. That way our new trigger instead is when space key pressed. So to jump, we will use the space key. And let's set how high we are going to jump with our new variable jump height. So feel free to play around with this number, and if you need to jump higher, you can make the number higher or make it lower if you don't need to jump that high. And then we're going to repeat until the jump height is back at 0 and equal to 0. So we are repeating until an action happens, and we are saying that the jump height must equal, so jump height equals 0 again. So we jumped up 11 pixels and we want to come down back to 0. But how are we going to come back to 0? That's inside our repeat until loop. Let's change Y since Y is up and down. Let's change Y by the jump height, since that determines the actual number of how high we're jumping. Let's change Y by jump height. And also we want to change our Y by, and also change our jump height by 1. That way our motion does the adjustment and our variable. So we can change jump height by -1 to decrease down to 0. And outside our loop, let's add in a wait block of 0.2 seconds. And let's test it out. Now, if we were to walk, we can jump. Now, that might be too little of a jump to make it over incoming balls coming down. So we can edit our jump height maybe to 15. And that'll give us some more jumping leverage. Make sure you can jump on the second floor. Just make sure your head never touches the ceiling. Mine's almost there, but it's almost just perfect. And make sure you can bounce your way up to the ending. That way, if our jumping works, then we can add in the dodging balls next. Dodging balls. So add a sprite for the ball or character you want to dodge. And make the ball sprite small enough that your character can jump over it. So let's go ahead and add a new sprite by clicking the cat image to choose a new sprite. And I suggest choosing a ball that's round, such as the ball. Maybe you have a rolling baseball, basketball. I've seen rolling earths before. Up to you. Just make sure your sprite is a circle. That way it rotates very well. Maybe you have a tennis ball rolling. But avoid things like the watermelon, the egg. That way we have a smooth round circle to roll. I'm going to be using the ball here since it has different colors. And one thing to make sure of, best way to see the perfect size of the ball is by putting the ball next to the character. And I suggest resizing the ball to at least half as tall as your player. That way your player can jump over it. So my ball can be a little bigger because I have more leverage. So maybe 60. Just make sure your sprite is able to jump over it. And you can test it out a few times by moving left and right and trying to jump over the ball while it's not moving. Once you have selected a ball, let's talk about cloning, since we will need more than just one ball rolling. Cloning. So today we'll be learning about how to create clones in Scratch. Does anybody know what a clone is in real life? We've seen them in movies and games before. Some are very popular examples of clones are in movies and TV shows are Star Wars, Avatar, the movie. So these are examples of clones having multiple copies of the same person. So we'll be using this cloning features to turn one sprite into many sprites. We'll do this by cloning that one sprite we chose as the ball. So here's a hint. When the green flag is clicked, we will hide the original ball. Then we will add a forever loop. Inside this loop, we will wait 5 seconds and then create a clone of the ball itself. So let's add the following code to your ball sprite. So let's make sure we navigate out of our Pico walking or your character walking. And make sure we're in the ball sprite. That everything we code now is here in the ball. That way all the actions happen here. And let's trigger our event when the flag is clicked. That way we can hide the original ball and then forever create clones of myself every 5 seconds. So let's hide the original ball in the looks section. And then let's go to control. That way we can consistently forever make clones of ourselves. So let's also create clones of myself, which is the ball. And let's do that every 5 seconds. So let's add in a wait block. That way it waits every 5 seconds to make a clone. Now, if you were to click the flag, you'll notice that the ball is gone. And you're not seeing any actual new programming code working. But that is because our original sprite is now hiding. So let's make our clone move. So we need to make our clone move from the end of the course towards our character. So let's trust these numbers out. So when we start as a clone, we will go to the top of the screen and then show. So let's try that. So now that we created clones, we have to start the new trigger as when we start as a clone. That way we can go to a coordinate, Let's go to the coordinates 160 and 160 for both X and Y. And then now we can show our ball. And let's try that. Let's click the flag. And nothing happens of the right now. And that's probably because the ball is way too up in the sky. Oh, there it is. And let's begin by dropping it down, rolling it, and then we'll add in the actions to make it roll further. So now that we started as a clone, you should be able to show it. And let's go by continuing the rest of the code by making it move. Let's repeat an action 22 times and then change Y by. So let's go into control to repeat an action 22 times. So 22 pixels down, and that's going to be changing the Y axis. That way we can drop the ball down. And let's try that. You'll notice that the ball drops down. Right, here we'll try it again. Wait for the ball to come in every 5 seconds, and then it will drop down. Let's repeat a new action. That way we can roll it to the left. So this action requires 170 pixels. And we will change Y by -4 again to go to the left. So again, we are repeating 170. So repeat 170. And instead, we're rolling on the X. So let's change X by. Let's do a negative number, -2. That way it rolls to the left. And let's continue our actions. Let's repeat 30. That way it drops down. Let's drop down the Y-axis now. So let's change Y by -4. And then this will cause the ball to drop down, roll across the 3rd floor, and then it will drop down to the 2nd floor. So repeating a certain amount of pixels will get you to the spot you want it. Feel free to try out to get your ball to the bottom of the 1st floor. Here's a cloning extra. I know our ball only reaches the 2nd floor, so let's modify our dodging balls by continuing our repeat loops. So we know that it drops down 30 pixels last, and that it rolls about 170 pixels across. So let's use the repeat loop, and let's try about 150 since it's not as long as the 1st floor. Let's try maybe 160 to be closer. And this time the ball is rolling on the X-axis last. So let's change X by, and let's go forward. That was pretty fast. So let's go forward by 2. And let's see how far it rolls out. Depending how far it rolls out, we will modify the ball to go a little further or stop a little sooner. So it stops right at the edge. So let's try 170 like original. And then we still need to drop it down another level. So let's repeat another action. And we know it's 30 pixels tall. So let's try 30 again. And then we need to drop down. So up and down is Y-axis. So let's change Y by a negative number since we're going down. So let's do -2. And then that will get your ball to drop down to the 1st floor at last. Let's see, was 30 pixels enough? Let's see. Let's try that again by refreshing the program. Clicking Save Now helps a lot too. And let's see. So every 5 seconds the ball will drop. And let's see, it's rolling across our repeat 70. Now repeat 30. Now repeat 170. Change X by 2. And let's see if the last action works. All the way down. It only stops halfway. So let's go a little more down. Let's try maybe 60. And that should get us to the bottom. And there's the ball. It reached the bottom. And let's do one more repeat. That way it can at least make it halfway to us. That way there is some room for us to run. So let's repeat maybe Let's do 140. That way it doesn't completely reach us. And then since it's rolling left and right, let's change X by -2 since we want it to go backwards. And let's see how far the balls can go now. And then it stops right about almost in front of us. So with this extra portion, you should be able to have the balls drop from all the way from the top, all the way as close as down to the player. So this was an added portion to our lesson. Let's move on next by getting hit by the balls. Getting hit by the balls. So when the ball touches our character, we want to go reset our player to the starting line. So whenever the ball touches your character, we want to broadcast a message saying that we got hit. So here's a hint. So when the ball starts as a clone, add a forever loop, and inside this loop, check if the ball is touching your player, then broadcast hit. So our trigger on top is a little different. Let's add this code to your ball sprite. So when we start as a clone, we are consistently checking forever if we are touching the player walking. Then let's broadcast a hit message. So we are still inside our, So it seems like we are the ball still, and then we are seeing if we are touching the player. So let's stop our program, that way our infinite balls don't keep reappearing. And let's add a new trigger for when we start as a clone, because we're watching out as clones for something. Let's add in a forever block to consistently check if something happens. And our condition is that if we are touching the player, so we are sensing that we are touching something. So let's use the first block, touching mouse pointer. But we're not touching the mouse pointer. We're touching the player walking. Because if we are touching the player walking, let's broadcast an event. So let's go to the event category and broadcast a new message called hit. And your code should look something like this at the end. So now we need to make your player go back to the starting line when hit by the ball. So now when I receive the hit message, let's go back to the starting point in the direction 90 and go to our certain coordinates again. So we will need to go back to our player sprite. That way we can receive the message there. So again, we made when I start as a clone, if touching player, broadcast hit inside the ball. But now the player sprite is receiving the message. So when I receive hit, the player knows that I got hit. So let's make sure that it points in direction 90 and goes back to the coordinates. So I like to make sure this when I receive hit block is near my original code. So I'm going to move it over to my first code. That way I can see where I originally started at. So when I receive hit, I will point in the direction 90 and I will go back to these coordinates. So let's go to -213 and -155. And let's test our code out by getting hit by the ball. Part of being a coder is testing out every instance, and that includes whether you have to lose or not. So I'm gonna prepare myself to get hit. Oops, I missed it. Let's try the next one. Boop, I got hit. And if I were to try and climb the ladder in front of me, I can't because the ball's in my way. So try to jump over the incoming balls that are coming your way. I'll get hit again for an example, and it should reset you. So our goal is to try to make it to the end of the obstacle course by the time we are still alive and not getting hit by the incoming balls. Let's try that again. Whoop. This game can get tricky, so definitely try your best now to get to the edge of the screen by touching the green bar. Whoops. And you win. Awesome, awesome. Let's add in some last minute features such as the laser that is not working at the top. Adding lasers. If you notice your sprite list, there's a laser sprite that we haven't used yet. So it is time to use these lasers. The lasers will turn on every few seconds, and if you touch it, you will start over. Have anybody guessed how to do this? Well, let's turn off and on the laser. We can do this by using its costumes. So the first thing we need to do is turn the laser on and off. We can do this by switching between the two costumes that were provided to us. Here's a hint. When the green flag is clicked, we'll add a forever loop. That way it consistently switches the costume to on, then waits 2 seconds, then switches the costume to off, and waits 4 seconds. Let's add this code to your laser sprite and test it out. So again, make sure you are inside your laser code, your laser script, and we can begin our new trigger here when the flag is clicked. That way when the flag is clicked, our laser will start to work. Let's consistently, forever, switch the costume to on, wait 2 seconds, and then switch costumes to off, then wait 4 seconds. Let's try that. Let's do a control, that way it forever works. And we are taking advantage of the costume it has, that it's off and on. So they already provided us the drawings. So first we wanted to turn on, so let's switch the costume to on. And you can play around with the wait blocks, because it will be on for 2 seconds. And then it will switch the costume to be off. And then let's add a wait block for how long to be off. Let's do 4 seconds like mentioned. And if you click the flag, you'll notice that the laser turns off and on. We have the lasers activated, but we need to check if we are ever touching the lasers to reset us. So now we need to check if our character touches the lasers while they are on. Can anyone guess how we do this? Well, we did something similar for the ball sprite. So let's add this to our laser sprite and testing it out by getting your player next to the laser. So we're going to be using the same code to broadcast that we still got hit. So let's add that to our laser. Let's say when the flag is clicked, we are consistently checking to see if the player that is walking gets hit. So let's do forever, consistently, if. So if a condition is ever true, such as touching the player walking, so touching Pico walking, and let's use the same broadcast hit block, because the same broadcast we use by getting hit by the ball, the same action will happen if we were to get hit by the laser. So I'm going to try my best to get up there without getting hit by a ball. Let's wait for this one to pass. And I'm going to try getting hit by a laser. Whoop! I tried going through the laser and it didn't let me. And that is because our broadcast hit is in effect. So let me try to win the game by waiting until the laser is open. And also making sure that the ball is not through the laser. So now you may need to modify some things. Maybe you jump too high, such as my player. I can't even jump through without touching the top. So perhaps editing your jump height may help you get across the laser. So remember, editing your jump height, maybe lowering it again to 13. That way when we jump through the laser, our heads aren't touching the ceilings like we mentioned in the beginning of the clips. So let me try my best now. This is not an easy game, so I'm going to try my best. Let me wait for this one, and whoop. Might need a little more jump to it. And try your best to dodge the incoming balls and the activated lasers. So that should be a good enough jump. Wait for this one. Wait for that one. And it's a challenging game. See if you can beat it on your own. I'm going to try one more time. Wait for it. And you win. So try it out all by yourself. Great job. You made it to the end of this project. If you really enjoyed the game, you can try some coding challenges on your own, and you can attempt the following. Maybe adding some more obstacles, more balls, more lasers, maybe perhaps making your gravity better. Sometimes the jumping can bug out a little bit. Perhaps adding lives to your game. So there's a lot of features to add. But if you have any questions while making this project, feel free to reach out to AI Code Academy. And this is the final code for this project. See you next time!